Hi, physics people. We are doing chapter 27 light next. So, with this chapter, it's best to actually look through the book. I will post a PDF of the book as well in case you don't know where your book is. So, make sure you look through the chapter to do tonight's homework. There might be some answers in there, and at least the first three sections. And I'm just going to go over just a little bit of the light notes for today. Okay? So, here we go. So early ideas. So Einstein was one of a few of those early scientists who came up with some ideas about light and how light worked. For most of history, light was thought to consist of particles. Light did not seem to spread out like waves. In 1905, Einstein published his theory explaining photoelectric effect. Light consists of particles called photons, which are massless bundles of concentrated electron magnetic, looks like there's a word missing, fields. The modern theory is light has a dual nature, part particle and part wave. So, the speed of light, short version, early experiments only measured human reaction time. Albert Michelson demonstrated experimentally with a rotating mirror and a stationary mirror to calculate the speed of light to be 299,920 kilometers a second, rounded to about 300,000 kilometers a second. For this, with this experiment with the mirrors, he was awarded the Nobel Prize in 1907. The electromagnetic waves, we've talked about electromagnetic spectrum before in a couple of different chapters. Here it is again. Light is energy that is emitted by accelerating electric charges, often electrons in atoms. There's those electrons again being oh so popular. It travels in a wave that is partially electric and partially magnetic. It's called an electromagnetic wave. Again, we've talked about those before. So again, this spectrum is not a new thing for us. Look at it again. Notice you have a range of electromagnetic waves represented here on the spectrum. You have the radio waves at one end, and notice how spread out the wavelengths are. Then you have microwaves, then you have infrared, then you have the ultraviolet, we have X-rays, gamma rays. Notice the frequency, huge up here, okay? There's a lot. Wavelength is shorter, but a lot more in frequency in hertz, okay? So this is called the electromagnetic spectrum. We can see only a very narrow portion of the spectrum. The frequency lower than red light is called infrared. The frequency higher, the violet, ultraviolet. Okay, so here we have um, the ultraviolet right here. We have violet on this end with the shorter wavelengths. Then you have the red on this end with the longer wavelengths. Okay. Notice the frequency is lower. Oop, I don't know if this just, there we go. And then the frequency is higher. Okay. So big difference there. And it's kind of, we're looking at it different than we looked at it on the other page as well. So up here, these ones were reversed on the other page. So here you have the X-rays, the gamma rays, the UV light, the microwaves, the radio, broadcast band. Okay. All right. I think this might be, yeah, this might be the last page I want to deal with. Light and transparent materials. Light is energy carried in an electromagnetic wave that is generated by vibrating electric charges. If those waves strike matter, electrons in the material are forced into vibration. Light vibrates at more than 100 trillion times per second, 10 to the 14 hertz, so has to have small inertia, the electrons. Okay, and I think that's all for now. Have a good day. We'll continue tomorrow.